everyone can hear and see me fine. You never know these days with technology, and this is a click meeting platform that we're using for today's webinar, but hopefully we should have a successful 75 minutes or so this morning talking about delivering low carbon civil engineering projects for a 2045 Scotland. Morning, welcome. My name's Andrew Wilson. I'm the sector manager for the Supply Chain Sustainability School in Scotland. We're pleased to be hosting the webinar this morning, talking about how we cut waste and cut carbon through our own direct operations and through supply chains to work towards the recent legislation that the Scottish Government has made to, in effect, have net zero greenhouse gas emissions by 2045. We've been really pleased to work in preparation for this webinar with SECA, the Civil Engineering Contractors Association in Scotland, and Zero Waste Scotland, who are a partner of the Supply Chain Sustainability School, and also the Scottish Environmental Protection Association. So I'll be facilitating the webinar this morning and introducing each speaker in turn. We hope to have a few minutes for Q&As after each speaker has presented. So if there are any Q&As, then please put them into the chat function of the webinar, and myself and my colleague will hopefully pick up on those and be able to direct those to each speaker in turn following their detailed presentations. That being said, we do have a record function this morning on this webinar, so everything's being recorded. So don't worry about jotting down any particular information from the slide deck, because you'll have all of that to hand after the webinar has finished, and we'll be providing a link on the Supply Chain Sustainability School website for everybody's reference, so they can go in and see and replay exactly all of the information that's been presented. We should also have some time at the end for general Q&A as well before we leave this morning's webinar. Okay, so just a little bit more information about the agenda. I'll try and keep my opening comments very brief, and then pass directly on to Clive Bowman, who's the Circular Economy Construction Manager for Zero Waste Scotland. Clive will then pass across to Chris Ewing, a consultant for Levenseat, who are a leading waste and resource management contractor, speaking really this morning on behalf of SECA, the Civil Engineering Contractors Association. Chris will speak about his work particularly on incinerator bottom ash aggregate and the environmental benefits that it has for the construction sector supply chains. Finally, we have Ian Watt, who's part of the managed delivery team for Scottish Water, who will be presenting on how Scottish Water are working to remove their own operational carbon, but importantly, the embodied carbon within their supply chains going forward. A few notes, first of all, about the Supply Chain Sustainability School. For those of you who aren't familiar, we assess supply chain sustainability competence across the country, across the UK, and we develop knowledge, collaboration, awareness and skills building on all aspects of sustainability. We're an online school now more than ever for obvious reasons, but we do, hopefully when the world returns to normal, we'll be continuing to present a lot of physical training, workshops and seminars as well. We work with 102 partners, and we've got over 300 active members within Scotland. So there are some of our partners there on the screen who we work with, and many of those join together to run a leadership group in Scotland that guides our work across the country. I said I'd be just very, very quickly. We've got a huge raft of online training resources, which you'll find when if you're not already, become a member of the school. And relevant to this morning's webinar, we've got a lot of resources on carbon, on particular carbon, on measuring carbon and reporting carbon and bearing down on your own direct carbon, scope 1 and scope 2 carbon. But also we're starting to do a lot more work on embodied supply chain carbon, scope 3 carbon, and producing a lot of support resources in that area as well. So we've got e-learning modules, we've got a whole raft of tools that are accessible from our website. We've also got some great videos, some great learning content on YouTube, on the carbon agenda, documents and web links as well. We provide resources and web links for third-party resources in one easy to manage sort of portal through the Supply Chain Sustainability School. So hopefully that's very quickly given you an insight into some of the work that we're doing within the school to increase knowledge on this really important item, this really important issue on sustainability. I'm going to now pass across to Clive Bowman. Clive's project manager for Zero Waste Scotland. As I said, we work closely with Zero Waste Scotland. They've been a partner of ours for over a year now, which we're really pleased about, and we're trying to collaborate as much as we can with this government agency. So Clive, over to you, and you're going to be talking about achieving zero waste within the Scottish construction sector.
Thank you, Andrew. Excellent. I'm really pleased to be here speaking today. I'll see scrolling down the list that we've got attendees, so that's excellent. First of all, I'm just going to apologise for living in quite a rural area, and the internet can be a little bit hit and miss, so it will help, I think, with stability if you can't see me. It will help with a lot of things if you can't see me, but that's one of the things anyway. So yeah, just to remind you, I'm Clive Bowman. Some of you will know me already. I'm the Circular Economy Construction Project Manager at Zero Waste Scotland, and I'm responsible for the construction business support programme that we deliver through the organisation. This programme provides free advice, guidance and training, and really a wide range of support for the whole construction industry. It does have a focus on SMEs, but by no means should we be limiting ourselves to that, as a lot of supply chains go right across the whole range of different size organisations. And we try and target, again, throughout the whole industry, so that would include planners, clients, developers, designers, procurers, contractors, facility managers, and all associated supply chains within that, whether that's manufacturing, the infrastructure and delivery and supply of plant and services and machinery, right through to decommission and to demolition contractors. So it's a big industry, and lots of different people can then access this free advice and support service. So I'm going to use the next 12, 15 minutes or so to discuss how the construction sector can achieve zero waste by adopting principally a circular economy approach. And also we'll talk about how, in a bit more detail, how Zero Waste Scotland is supporting the sector to embed that circular economy approach throughout all of its ways of working. So first slide then, please, Andrew. So first of all, some stats to set the scene. I think this is quite useful. We all know the construction sector is large, very large, in fact. Around about 10% of the economic activity in Scotland is related to this sector and employs around about 10% of the workforce. But it has a disproportionate environmental impact. So as you can see on this slide here, 50% of Scotland's resource consumption is within this sector. And it's also a big producer of waste as well, around about 50%. It's also responsible for about 40% of carbon emissions. We can also see on this slide as well that it has a big impact in terms of plastics. So this is a UK figure, generates around about 50,000 tonnes of plastic packaging waste each year. And that's 3 times more packaging waste than all of the UK households combined. So we're a big sector and we do have a big impact. But it's not all doom and gloom, though. I think the sector is doing well in terms of recycling. It has a very good recycling rate, and I put that recycling inverted commas. That rate is around about 90%. But the caveat is that this is mostly for inert material, aggregate and soils. And when we talk about recycled, quite often in construction, we're talking about downcycling. So maybe waste wood and waste plastic is going for heat recovery, or plate glass is broken down and used in aggregate or in road paint, for instance. The other partial good news is that the energy performance of buildings has significantly increased over recent years. And yeah, that's really going to some good work there. Building standards have significantly improved in that respect. And we are working quite well towards a zero operation carbon house on building in the near future. But this does lead to some issues. So we have issues, poor indoor air quality, for instance. We have issues of overheating through solar gain, perhaps, and definitely there is performance gaps that are perhaps exacerbated through lack of post-occupation evaluation and this kind of assessment. So energy efficiency measures do reduce carbon emissions from building, but that's only half the story. And this slide really shows that that literally is half the story, because of that 40%, half is embodied energy and half is the operational energy. So the embodied energy, the embodied carbon, is the carbon that's associated with the materials themselves and the activities of getting those materials to a site and putting them in a building. It also applies to the surplus materials that are unused and discarded during construction. So it's a really important aspect, that 50%, that half of the carbon that we use. So it's clear then that if we use less materials and we use the right materials and we waste less materials, then we can lower the embodied carbon footprint of a construction project. And just to kind of reiterate that, then if we use less materials overall, and those that we do use have less energy in their manufacture and transport to site, then this could lead to cost savings, wider environmental and social benefits. And I'll come on to talk a little bit more about that throughout this presentation. So next slide, please, Andrew. So one of the keys to using less materials and avoiding waste is to think about the waste hierarchy. You'll be familiar with this, hopefully, and you'll be familiar with the mantra of reduce, reuse, recycle that you've perhaps heard, whether it's through your local authority or even adverts on television. So looking at this simple pyramid, the higher up this pyramid our actions are, then the closer we effectively will be to zero waste. So the avoid, reduce, reuse, and recycle, and that is proper recycling where we're retaining the value of the material. These are all actions that are currently and could, with more effort, be delivered by whole life cost approach, for instance, by spatial planning policy, by adoption of some digital technology solutions, certainly by off-site construction, thinking about whole life carbon assessment of projects. And I think as we look towards the future through extended producer responsibility and policies such as that. And then when we look down at the lower end of this waste hierarchy pyramid, we see downcycling, recovery, and disposal. And there are obviously elements there to discourage that. We unfortunately haven't got SEPA speaking today, but they were going to speak about aspects of duty of care and one planet prosperity. But that is one of the key elements to discourage these lower down aspects of the waste hierarchy. And obviously we have landfill targets as well and landfill tax, which all helps as well in that respect. So in simple terms, I suppose the higher up this waste hierarchy we are, the more circular our activities are. Certainly avoid, reduce, reuse, very much circular activities. And the lower down, the more linear we are. So what we're trying to do is move away from this linear economy and move up towards a circular economy. So next slide, please, Andrew. So this is a diagram of the circular economy, a very simple diagram, but effectively it's about retaining the value of products and materials for as long as possible and keeping them in use within a closed loop system. So that's reducing our non-renewable raw material inputs. That's the source aspect that you can see on this diagram, and minimizing any leakage of waste materials. So that's that cross that I've got there in incinerate and landfill, and very much trying to then keep that within this closed loop system. But it won't just happen by chance. It's something that we're going to have to make happen. We're going to have to work towards, and it's an approach that really needs to be designed in to all of our activities and designed into our physical infrastructure as well and planned for it to happen. So if we plan to reduce our resource use and waste generation from the outset, and then plan to maximize the value of our unavoidable waste, we think about it as a commodity, then we're going to move from this linear economy to this circular economy that I'm showing here on this diagram. And I think one of the key points that I'd like to point out is that if we adopt this approach and we plan and design and construct and maintain to replace our buildings and infrastructure, then we are not only going to use less materials, create less waste, but also all this list that I've got here on the bottom of the slide. So we're going to create jobs in a green economy. We're going to reduce capital and operational costs. We're going to increase business and supply chain resilience. We're going to improve economic stability, decrease carbon footprints, improve environmental quality, and improve building quality. So these are all win-win opportunities that we can get through a circular economy. So it is a very broad approach, and it has a broad range of positive benefits from it. Next slide, please, Andrew. Thank you. So the concept of a circular economy approach can be adopted by applying a number of principles. And I've kind of brought these down to 10 key principles. This slide shows the first 5, and the next slide will show the next 5. They're in no particular order, and it certainly isn't by any means a fully inclusive list. Some of these principles or activities will have more impact than others, and some are definitely easier to achieve than others. But I think it's a useful list, and if there is a construction project wanting to be more circular, reduce its environmental impact, certainly work towards zero waste, then consideration of all these 10 principles in all decision making is probably the way to go forward. So I'm going to go through each of these one by one and just give you a little bit of a summary of what I mean by that. So first of all, collaboration. So to successfully embed circular economy principles throughout the construction industry, we need to collaborate. We need to align our objectives right across policy levels and supply chains and stakeholders for the whole life of a project. And that's really important, our whole life. We need to pool our expertise and experience and share the resources and ensure all our opportunities are taken and grasped to deliver best practice. And we can share that best practice as well. So collaboration is the key. I think that's one of the higher ones on this list here. Health and well-being, that's my number 2. We need to design and maintain all of our infrastructure, both indoor and outdoor spaces, to maximize quality of life, comfort, productivity, mental and physical well-being. So this includes things like air quality, active and low carbon travel opportunities, maybe flexible and adaptable working and living spaces, a bit like we all have now, working from home. It also includes quality green spaces, good neighborhoods, and social connectivity. And the reason that I've included this in the circular economy principles, because it has that greater knock-on value throughout the whole of society and really the ecosystem, that if we start thinking about circular economy much broadly, we can start to reduce resource use on a much broader scale. And when we think about resource use, we're thinking about it in its broadest possible definition. So we're not just thinking about materials per se, but we are thinking about energy, we're thinking about people, we're thinking about expertise and productivity, and all the kind of natural capital that we have out there as a resource for everyone as a population. Number 3 is long life, loose fit. Now this is an architectural term, some of you are familiar with, others perhaps not. So I'll just give you a quick summary of what I mean by that. So we need to design and construct buildings and infrastructure that last longer. So it's all about quality in materials, making sure that we're building longer than we currently are. We've got a very short time scale at the minute in terms of how we expect our buildings to last. And when we do build better and we build them for longer, we need to then ensure that they are able to evolve and adapt through time to reflect the changes that will happen in the future. So it might be fashion, it might be use, it might be need, it might be demand for different uses of buildings, but also there's going to be change and impacts such as climate change, population, digital technology changes, demographic changes. So there will be a difference in the way that we've used buildings, and we can look back in the past at buildings that were built several hundred years ago. Now we're quite often using them in a different way, and we've adapted them. And those that have been adapted successfully were designed to be able to be adapted. Good, solid structure, open space interiors that can be adapted and be flexible. So we need to think about that as we move forward with all of our infrastructure, make sure it's quality built and it's adaptable for change. And if we do that, we then minimize the wasted resources that might come if we have to adapt something or knock down something and replace it that wasn't built right at the first time. Number 4 on my list is low carbon and sequestration. We need to design all of our infrastructure to facilitate a low operation carbon and a low embodied carbon and a low resource use society. So this is all about all of our built assets and all of our landscapes and all of our land use. We need to think about how we can then sequester carbon into those. Or obviously we can do that in some of our landscapes by retaining soil, planting trees, etc. But we can also do that within our built assets. We can use much more timber products, whether that's wood fiber for insulation, whether that's timber structures, or hemp insulation. We've got lots of alternatives where we can actually bring carbon back into a building. There is CLT, compressed laminated timber, that's been used throughout the UK and abroad for many decades now, but it's still not been adopted. And I don't know why particularly, because it's a fantastic opportunity to sequester carbon into buildings. So it's something that we should look at a lot more. Number 5 on my list is smart construction. And this covers a wide range of things. So it covers digital technologies, including BIM technology. It covers modularization. It covers a range of modern methods of construction, including off-site construction. And all these will help increase resource efficiency. They will help improve the quality of our built assets, and also they will help monitor performance, which is really important. And that goes back to one of my points earlier about us having that performance gap and not, sorry, I just got something coming up on my screen there. And yeah, I'm not being able to access the information that we need to make sure that we're delivering our infrastructure that's fit for future. So next screen, please, Andrew. Number 6 on my list is whole life value. And again, I've talked a little bit about this, but it's thinking that the upfront construction costs of a construction project or a building are not the only type of cost. The key to us having a sustainable future and a sustainable infrastructure is that we need to think much broader. We need to think about carbon reduction and zero waste and take a wider, longer term view. So we need to consider those lifetime positive and negative impacts of a building on society and the environment. And we need to think whole life. So it's not just construction, it's throughout its own whole use, its maintenance and its repair, and its decommissioning and disposal. Number 6 is all about material recoverability. So we need to design right from the start for deconstruction to ensure we have 100% material recoverability at the end of life. And this does require pre-planning. So we need to get designers, clients, facility managers, contractors, and demolition contractors involved early on to think about how we're going to dismantle and recover the materials from the buildings that we're putting up now. We also need to establish an infrastructure framework and network of regulation and quality control that allows a consumer market to emerge for all this reused material. That's really important. That's something we don't have at the minute. Number 8 on my list is design out waste. We need to plan, design, maintain, and decommission all of our built assets in line with that waste hierarchy I showed you earlier. And by doing this, we will minimize the unnecessary use of primary materials and promote the efficient use of secondary materials. Number 9, circular material. This covers a wide range of thoughts as well. So we need to, under this one, think about maximizing the utilization of all of our assets, all of our infrastructure, all of the components within that, all of the materials. We need to particularly think about using renewable materials rather than raw materials that we're digging out the ground and unable to renew. We need to think about using recycled materials, pre-used materials, surplus built assets, products and materials. So there's a lot here within the circularity. We need to use local materials as well, and materials from natural sources. So some of these can be returned to earth at the end of the life without any impact as well on the environment. And importantly as well, as part of the circular materials, it's how we use them. So it's those alternative business models that we can put in place to facilitate circularity, such as servitization. And this is there's a whole area within this that we're going to be looking at in the future as well. And lastly, on my list of 10 is material management. And this does include site waste management, but much broader in terms of material management, I would like to kind of get you to think about. So thinking about best practice management of all construction materials, right from specification and ordering, right through to how we package and deliver those materials, how we handle them on site, how we store them, how we use them, and then how we reallocate the surpluses, perhaps at the end of a construction project, to make sure that they get into that infrastructure framework where we want to have reuse of materials. And we can do this by using a range of tools and also design that in from the start to really make sure that we retain those material values. Okay, next slide, please, Andrew. So circular economy principles should then, I think, having looked at that full 10 list, influence all the decisions that affect the form, the quality, the spatial arrangements, and the wider contribution potential of all development, all infrastructure, and all land use. And so circular economy can do much more than deliver zero waste. It's an important route to that. But let's always think bigger. And I think one of the things that we can think about in terms of taking the circular economy approach is that we can look at it at a placemaking scale. And that's really important when we start to think about planning and national planning framework policies, for instance. Because if we start thinking bigger than zero waste, and we start thinking about circular economy placemaking, we can start to affect things like air, light and sound quality. We think about the movement and mode of transport of people and materials around our country. We can think about the choice of and accessibility of resources, products and services throughout the industry. And then the productivity, the cost of living, the access to social, natural, cultural and leisure needs as well throughout the country. And of course, the health, well-being and behaviour of society and of our whole ecosystem. It has the potential to have an impact on. So, this phrase that I've got in the box at the bottom there, a circular economy approach, will consider all of these for current and future generations, is really important. Let's think big, let's think long term, let's think whole life value. And that's the kind of key message I want to get across here. Next slide, please, Andrew. Zero Waste Scotland provides support, as I said in my first slide, throughout the construction industry. And the way that we approach this is very much on a collaboration basis. We are looking for collaboration opportunities all the time to try and provide added value to construction projects. We can help enhance construction projects to be more sustainable, lower carbon and better whole life value, as I've discussed in these couple of slides. But we do have 4 particular themes that we try and focus on, because it is such a broad subject and it is such a broad industry, as you know. So particularly thinking about working with clients and designers in terms of brief and early design development, that is a key. And it is a concept that's well recognised throughout all circular economy approach, that the earlier that you can get in, particularly through design, you can have more impact in terms of changing the way that you do things. So that is a real important aspect for us to be able to target clients and target design teams. The second on my list is, again, targeting clients and project and contract managers and QSs and talking about sustainable procurement. And again, bringing in this concept of whole life value and whole life cost. The fourth theme that we try and focus on is that whole site material management. And again, here we can target contract and site managers, but also bringing it forward, because it's important that, again, aspects are designed in from the start, so we can start to work with designers, we start to work with clients and QSs to ensure that site material management best practice can take place. And then we can also work with a range of people within the industry right across the whole supply chain to adopt digital technology solutions. And this might be BIM, building information modeling, or it might be asset management, or it might be other communication digital technology. It could be visual communications, such as using VR or AR, or it could be drones with cameras to help survey, or infrared. So there's loads of different digital technologies that can really improve the efficiency and minimize resource wastage. So that is our fourth key theme. We have a number of tools, guides, and training courses on our website, and I've just got a couple of images to show you there, some of them, such as the Procuring Resource Efficient Construction Project Guide, or the Design Out Waste Construction Guide, or the Construction Material Exchange Platform. But there's several more on the website, but also we're very keen to signpost to other resources. The Supply Chain Sustainability School has got a massive amount of resources on it, a fabulous resource place to go and visit. So I really advise you to go on that. But also there is others, Construction Scotland Innovation Centre, again, a fantastic range of resources. So we do work a lot with partners to make sure that the whole industry has access. We align our resources and make sure that we're not duplicating as much as we can. And I think certainly with the current COVID-19 situation, it's a real good opportunity for a lot of you to access some of these resources, look at some CPD opportunities and keep up to date. And it's an opportunity for us as well at Zero Waste Scotland, and I'm sure Andrew is doing the same, as taking that opportunity to ensure that all our resources are up to date as well. We continue to support the industry through best practice examples as well, and I think one of the things that we're constantly looking at is case studies and trying to promote these out as well through a range of seminars and workshops. So such as the one today, where we come in partnership with the Supply Chain School and Seeker, but we've got a number of other events that we're planning throughout the year, and we work quite closely with partners on this. So it's if there are people out there listening just now that are part of an organisation that want to be part of a future workshop, whether it's in the near future through a webinar, or perhaps hopefully when we're back face to face in the autumn, or later we start doing some live face to face workshops, then that'll be great. Please get in touch with me, because I'm always looking for new partnership opportunities.
Clive can't answer that.
Okay, thanks, Andrew. 5 minutes. Nope, back one. Sorry, Andrew, not finished that yet.
Sorry, Clive.
That's all right. And just on this slide, then some of the things that we're doing to support the industry as well is thinking about the gaps in terms of knowledge and research and policy guidance as well for Scottish Government and other policymakers. So one of the areas that we're working on just at the minute is embodied carbon, but we're also been supporting the National Planning Framework consultation response, and we're going to be looking at building regulations over the coming 12 months. So there's a number of aspects that we're working on as a team as well to provide both that support to the industry, but also kind of work behind the scenes to try and improve the situation for everyone. Okay, yeah, I think that's it. You can move forward now, Andrew. Thank you. So that's me. Thank you for listening. And as I said before, feel free to contact me. Here's my email address. I'm on LinkedIn. If you want to particularly discuss anything I've said, you want support directly through Zero Waste Scotland, you perhaps want to be part of a future webinar or seminar, yeah, I'm always here, and my colleague as well, Stephen Boyle and Nick Ribbons, are always available to have a chat about any construction aspects that we can provide you with through Zero Waste Scotland. So thank you very much for listening. Pass you back to Andrew now.
Thanks a lot, Clive. Thanks for that excellent introduction to this morning's webinar. Some real sort of strategic input there from Zero Waste Scotland on all of their work and the key aspects of developing and furthering and accelerating the circular economy principles across Scotland. We've got now Chris, if the slide deck works, just let me try and select that. We've got Chris Ewing, who's a consultant with Leven C2, as I mentioned at the introduction remarks on the webinar, are a leading resource management and recycling company based in Forth, Lanark. Work closely with CPER, Scottish Environment Protection Association, and member of CIWM, Chartered Institute of Waste Management. And Chris is going to talk in particular about their work connected to circular economy, and in particular IBAA, incinerator, bottom ash aggregate, and its environmental benefits. So Chris, with no further ado, I'll pass over to yourself.
Okay, if we could get the next slide, please. And the next one. Next slide. Thanks. Yeah, what I'm going to cover this morning is, as you can see in the slide there, a brief introduction to Leven C, then chatting about what IBAA is, anticipated volumes in Scotland over the next few years, how it's produced into, or how the IBA is produced into an aggregate, and how that's aggregate is currently used at the moment. But more importantly, I think, what's its future potential and what are the carbon benefits of using this material. So, next slide, please. A quick introduction to Leven C. Andrew's already touched on who we are, where we are, and what we do. As he mentioned, we are located in central Scotland. We're a family-owned resource management company, been operational for about 30 years. Principal activities include production of non-structural concrete blocks from recycled aggregate, organic waste treatment, materials recovery, energy from waste, and organic waste treatment. We're currently assessing opportunities around the treatment of incinerator bottom ash from EFW facilities, energy from waste plants, a number of which have sprung up across Scotland in recent years, and more are due to come online over the course of the next 2 to 3 years. And the interest there for us is twofold. One is these ashes contain significant volumes of ferrous and non-ferrous metals, which clearly have a significant value and have a significant carbon benefit relative to producing those metals from virgin sources. But there's also the potential to produce a low carbon aggregate for use either as general fill or for use in bound applications like non-structural concrete products. And that's what I'm hoping to focus on today, partly to introduce this for those who haven't given it any significant thought previously in relation to possible use in your sector, but also hopefully to gauge what the interest may be or may not be, and what concerns there might be in your sector in relation to the use of this material moving forward. So next slide, please. Very, very quickly, this is just an aerial view of the principal site at Leven C, which kind of sets out the main activities there. I won't go through them in detail, I've mentioned them earlier, but what hopefully it does show is a very busy, integrated operation from an organisation which is pretty dynamic and has, as I've said, been operational for the last 30 years. Next slide, please. One of our more significant operations, and significant in relation to this morning's presentation at least, is a wash plant, where at the moment we process street sweepings and sewage screenings to produce a sand and an aggregate for use in our concrete blocks. And that wash plant could be used to wash IBA or IBA aggregates to remove soluble metals and chlorides to advance the opportunities to gain end-of-waste status for this material. And it also has the benefit of removing, or should have the benefit of removing, more of the non-ferrous and ferrous metals, which add to its interest in terms of its carbon benefits, but also potentially means that the sale of the aggregate might be capable at a more attractive price. Next, please. Next slide, please. Next slide, Andrew. Okay, just a quick note on the concrete blocks that I mentioned earlier that we make principally from recycled materials. Probably about 75% recycled content in those Levco blocks at the moment. As I mentioned, non-structural concrete blocks don't contain any cement, and principal uses, as you can see there, are for storage bays, retaining walls, silage pits, separation walls, salt storage, and the like. And those, that is a process which could benefit from the use of IBA or IBA aggregates, as we would have the potential to introduce more of that aggregate into the process and perhaps remove completely reliance on non-recycled material in the production of those blocks. Next slide, please. So on to incinerator bottom ash aggregate itself. It's 100% recycled aggregate arising from incinerator bottom ash. And as I mentioned, a mini explosion in the production of this material in Scotland over the coming years as a consequence of the commissioning of a raft of new energy from waste facilities to deal with principally municipal solid waste. Composition is 80 to 85% mineral fraction. Of that, about 9% is silt, which doesn't have a particular use for anything at the moment, but 10 to 12% metals, of which 2 to 5% are non-ferrous. There are substantial greenhouse gas savings in the use of this material, particularly because of the savings around the recovery of metals, and in particular non-ferrous metals like aluminium. And for the remaining part, uses for the remaining part after metal recycling, as I mentioned, are low carbon construction materials. Next slide, please. So this slide gives you an indication of projected production of incinerator bottom ash in Scotland over the next 5 years or so. In Europe, the annual production is around about 19 million tonnes, and that's just a function of the size and scale of energy from waste plants across the continent. But in Scotland, for plants that are either in operation at the moment or are currently being built and or commissioned, the production of IBA is circa 220,000 tonnes a year. But if we take a reasonably conservative view on the number of additional plants that might come online over the course of the next 5 years, there's a potential for up to 400,000 tonnes of IBA being produced in Scotland at the moment. And at the moment, there are not a significant number of outlets for the aggregate fraction of the incinerator bottom ash. It's an issue that energy from waste operators are acutely aware of and keen to move forward on. Next slide, please. In terms of processing the material into an aggregate and removing the metals are removed at a number of stages through a crushing and screening process. So the material goes into the process probably 300 mil or plus 300 mil down, and is crushed and screened down into the ranges of the sizes that you can see on the screen there. And that's principally because that's the most effective way and most efficient way of getting most cost-effective way of getting most of the ferrous and non-ferrous metal content out of the aggregate, which is where, to be honest, the significant value is in terms of its commercial interest. And as you can see, the ferrous and non-ferrous and the stainless steel are removed at each stage of that particular process. Next slide, please. There are, as I mentioned, significant carbon and environmental benefits associated with incinerator bottom ash aggregate, and that's, as I've kind of laboured the point, is primarily associated with the recovery and recycling of metals. But that's the potential carbon saving, as you can see there, in relation to the use of virgin aggregates, is around 300 kilograms of carbon dioxide per tonne of IBAA compared to virgin aggregate, and that's a pretty significant saving in anybody's book, I would suggest. And if we take, based on the CEPA position statement for the use of this aggregate in unbound applications, which I'll come on to later, but the use of just under 5,000 cubic metres or 6,500 tonnes in unbound applications could save nearly 2,000 tonnes of carbon dioxide relative to virgin aggregate when we take into account the benefits of metal recovery. Also, as other obvious environmental benefits, it closes the loop in relation to household waste, where most of this most of the feedstocks from energy from waste facilities are coming from, reduces requirements on the use of virgin aggregates, and has the potential to extend the life of existing quarries and thereby delaying the need for the development of new quarries in the kind of timescale that might otherwise be required. Next slide, please. So, current permitted uses of incinerator bottom ash aggregate in Scotland are constrained by a CEPA position statement in relation to its use in unbound applications, and you can see some of the key issues there. It can be used as a sub-base or general fill and roads construction platforms, where it's covered with a low permeability surface or buildings, has to be manufactured only from non-hazardous IBA, and must be manufactured in accordance with relevant aggregate standards and specifications. But crucially at the moment, it's limited in its use in any single project to less than 5,000 square metres with an average 5,000 metres with an average thickness of less than a metre. So somewhere around just under 5,000 cubic metres. So that is a particular constraint at the moment, and something that we are keen to move forward on in relation to potentially treating the aggregate to secure end of waste status. Next slide, please. So yeah, in terms of future potential for bound applications, there's the potential to use a very large proportion of the aggregate as a sand and aggregate replacement in concrete manufacture, subject to securing end of waste. And similarly for unbound applications, treatment which would predominantly involve washing to remove soluble metals and chlorides to secure end of waste would in theory enable unrestricted use of the IBA aggregate as a general fill and for other purposes. One thing that I need to avoid talking up in relation to this aggregate is its use as a particularly high quality material. The expectation is that whether it achieves end of waste or not, it's going to be a general fill material or potentially a material that can be used for the production of concrete in replacement of sand and other aggregates. Next slide, please. So the next steps for us are firstly market assessment, and that's, as I mentioned, that's part of the reason for asking if we could be involved in today's webinar, was to get some feedback from people who are on it in relation to potential interest in the product, to understand what the concerns might be, what questions that you guys might have about the product, and what questions you might have around quality issues, timescales, etc. Following on from that, we are in the midst of putting together or considering proposals for an aggregates production facility, which hand in hand with that, developing a procedure and protocol for potentially securing end-of-waste for both bound and unbound applications. Next slide, please. Next slide, Andrew. So questions from me to you really are, is there an interest in a lower carbon aggregate from potentially from IBA? If there is, when and under what circumstances would that interest be manifested? What are the key issues that the market needs to have addressed to make the product attractive? And given the key focus on carbon reduction across society, but in particular within the construction industry, is there any interest, or would there be any interest in the industry paying a small premium for the production and use of a lower carbon aggregate? And that, I think, is me. What I should have left on or put on a slide, which I forgot to do, unfortunately, was my email address. So if anybody's interested and wants to take it down and wants to drop me an email in relation to this presentation or any other issues around IBA, my email address is chris.ewing@leavingseat.co.uk. And I think that's me, Andrew.
Thank you very much, Chris. Yeah, apologies first of all about some of the slides sticking. I was pressing and keeping up with you.
Okay.
I assure you, but it's just a sort of lag in terms of sometimes moving the slide deck on. Thanks again. Good stuff, good content around that new product that's being developed by Leaving Seat, and hopefully we'll have a number of people on the webinar who've listened to that, who will come back to you with inquiries and requests for further information about that particular product. So thanks again for that. Just before I move on, we've had a question, hopefully people will be able to see it in the public feed, from Brewster Brothers, also related to use of aggregate, actually, as it happens, particularly in terms of incorporating backloads of aggregate into muck shifts off-site. This is a question from Scott at Brewster Brothers. So I've dropped that into the public feed, and any contractors taking part in this morning's webinar, please feel free to comment on that question. I won't read it all out, but it's quite a detailed question concerning incorporating backloads of aggregate into muck shifts off-site, and the cost savings, the time savings, the efficiency savings that could produce for the industry. So it'd be really interesting to see if any contractors come back to Scott on that particular issue. Moving on, we were due to welcome Matthew from SEPA, the Scottish Environmental Protection Authority. Matthew was going to speak, as Clive hinted at before, about the One Planet Prosperity agenda within SEPA. Unfortunately, Matthew can't join this morning's webinar, but he's given his details there for anyone interested in hearing more about SEPA's work, about SEPA's regulatory work and advisory work in terms of complying with licenses, exemptions and duty of care, waste minimisation, and going beyond compliance, which is an important message for the industry. There's the relevant details there for the National Waste Unit within SEPA, which I hope will be useful. A reminder that all of this is recorded, so all of the information that you're seeing on screen will be available via the website. And Chris was giving his email address before. We'll also put in the chat box as our next speaker is presenting. We'll put some email addresses and further information on that feed. So you've got people's details if you want to approach them for more detailed questions. Moving swiftly on, Ian Watt, I'd like to welcome now. Ian's a capital investment delivery manager for Scottish Water, working within the SR21 transformation team. He brings over 30 years of experience in design and construction of water and wastewater projects. Ian is joining us to talk on behalf of Scottish Water about what they're doing to reduce their own carbon emissions and, importantly, their embodied carbon through the supply chain. So Ian, thanks for joining us this morning. Over to you.
Okay, thank you, Andrew. Yes, as you said, I'm part of the Capital Investment Directorate. Within Scottish Water, we've recently appointed a carbon general manager and a team within our strategic customer services planning team, and I'm the capital investment link with that team. As you said, today, just want to give everyone a flavour of the journey that we're on and the work that we have started with the supply chain. So if you could go to the next slide, please.
Just 1 second. Got it.
Okay, thank you. So going to start the journey here, take everyone back to May 2019, when the Climate Change Secretary, Rosanna Cunningham, gave a statement to the Scottish Parliament. That was essentially the declaration of the global climate emergency. This was followed in September with the release of the Scottish Government's Programme for Government. And in that, the Scottish Government asked Scottish Water to take the lead in setting out and pursuing action towards a vision that will ensure Scotland's water sector will help secure a sustainable future and inspire a hydro nation. So no mean feat. But within that document, you'll see on the right-hand side of the slide here, the sort of kind of key commitments in that around hosting or generating 300% renewable electricity by 2030, being net zero by 2040, so 5 years ahead of the 2045 target. As usual, the government is keen to give Scottish Water challenging targets to aim for. It's also worth mentioning that this target includes embodied capital carbon, whereas down south, England and Wales, the target down there currently remains operational carbon. However, I do understand that the drinking water quality regulator down there is keeping a keen eye on what's happening up here in Scotland, with a view to challenging companies down there to follow suit. And finally, they asked us to produce a route map in 2020. Now, the draft of that route map was actually with the Scottish Water Board last night, and the final route map will be published later this year. So if you could go to the next slide. Given the emergency in the last year, Scottish Water has refreshed its vision, and what we see on this slide is our strategic framework. Around the perimeter are the 3 strategic ambitions, and you'll note that beyond net zero is the one that's at the top. And working towards the centre of the circle here, you'll see our 10 strategic business initiatives, which all sort of kind of link to the 3 ambitions. And in the centre is our vision statement, which has also been aligned to Scotland's water sector vision. What we were keen to do in Scottish Water was ensure that any vision that we had was not at odds with the wider water sector vision. And what it also aligns to is the United Nations Sustainable Development Goals and the Scottish Government's National Performance Framework. So essentially just wanting to ensure within Scottish Water we were aligned to the wider water sector. Next slide, please, Andrew. Now, I mentioned embodied emissions, and based on a 2017 Green Building Council report delivering low carbon infrastructure, it highlighted the figure on the right hand side, sort of kind of showing the growing importance of embodied emissions. This was also highlighted again in the January 2020 Infrastructure Commission for Scotland report, the Blueprint for Scotland. And again, it just demonstrates if we continue to decarbonise the electricity grid and the operational emissions continue to decrease, on the capital side, the importance of the emissions there will more than double as time goes on. Next slide, please. Now, looking at what we mean by embodied capital carbon, this includes emissions from raw material extractions, emissions from products that we use and produce. It also includes the transportation of all the materials through to construction. Now, operational emissions are also added to give the whole life emission. On the operational side, Scottish Water has been measuring these and tracking these since 2004. And data is available in our sustainability reports that are published annually. And these are available on the Scottish Water website if anyone cares to look for them. The embodied capital carbon is a newer reporting area for us and will be included in next year's report. To date, Scottish Water has only been measuring the capital carbon of its larger quality programme projects, and these projects are generally greater than £1 million, and where there is extensively a civil engineering construction element to it. So far to date, within Scottish Water, there's only a small number of projects where we've actually been looking at the capital carbon, but obviously that will change as we go into the next investment period. Next slide, please, Andrew. Moving on to our integrated supply chain, within Scottish Water, there are circa 400 suppliers that cover all the areas shown on the integrated supply chain map on the left-hand side. As you see there, that covers from our consultants to our contractors, to the kit and material framework providers that you see at the bottom of the screen. And as you would expect, these cover all areas of Scotland, including the islands. So all our frameworks need to ensure that we cover the whole of Scotland. The supply chain will be key in supporting Scottish Water achieve the 2040 net zero deadline. As frameworks are renewed, carbon will play into the decision making of the renewal of these frameworks, so that going forward it will continue to be, it will be a balance of cost and carbon that's taken into consideration in the award of frameworks. We'll also need the support of the supply chain to share data and intelligence, particularly in the MEICA and ICAT areas where there is currently limited carbon data. So within Scottish Water, there are, well, within the industry as a whole, there are still some data gaps that need to be closed. Next slide, please, Andrew. I mentioned the cost of carbon. Overall, it's envisaged that because that we will want low carbon materials and installation, that it will actually cost us more. However, based on data from other water authorities, it has been demonstrated and shown that low carbon generally does come with a lower price tag. However, we do recognise that there will be projects where there will be outliers to that rule, and we're putting in place governance that will account for these situations. So, we are conscious that in some cases, a carbon reduction might come at a premium. Therefore, we will adopt our governance to ensure that, that's taken into account. Next slide, please, Andrew. This slide shows a project life cycle in a fairly simple diagram, and what it's trying to demonstrate moving forward, that depending on the complexity of the projects that you'll see on the left-hand side scale, it will determine the number of gateways and how quickly we can get projects to the supply chain. So if you take the example of a simple replacement or refurbishment type project, that will very much go along the bottom of the diagram. So quickly going through policies and procedures within strategic customer service and planning and our operational college and customer service delivery, those projects will go more directly to the supply chain. Whereas again, if you look at the quality enhancement type projects, which will be more complex and at the top end of the diagram, they will go through more gate reviews, and all through that we'll be looking at trying to reduce carbon through the design, through the detailed materials, and also through the construction techniques. Obviously, to get to net zero, we need to look at all areas and how we reduce carbon in each of the key areas. Okay, Andrew, next slide. Now, in the next couple of slides, just going to give some brief examples of what is happening now. Interestingly, when you look at this, there are examples where we have been reducing capital carbon, although we've not always recognised that we've done it, and we've not always captured that we are doing it. The first example here is a growth project at Winchborough that's still currently in design. However, a recent technical design review, the use of concrete tanks was challenged, and the material was subsequently changed to stainless steel. Now, as you can see on the right-hand side, that's half the amount of carbon in that one element of the project. In addition to the material carbon savings, there will also obviously be safety benefits and also program benefits. Now, these are sort of kind of being worked through as we speak by the project teams. Next slide. Moving on to our modular transportable treatment units, or TTUs for short. In the last investment period, we've had 2 or 3 of these units somewhere in the project life cycle. And over the period, there has been continual improvement in the design, in the size of these. So you can see that from version 1 of a TTU to version 8, where we are just now, we're now in the design and in the construction using less steel in the frame, using less cladding, reducing the amount of concrete that's in the foundation. We're also just about to bring one of these modular transport units back from Mull, and we're going to repurpose it for use at Dalwhinnie. So this is where we're actually getting the benefits, the carbon benefits of reusing existing units. Now, there will be modifications required to the units as they come back in, but as you can see, we're starting to, adopt more carbon-friendly construction going forward. On to the next slide, Andrew, please. So kind of to finish the webinar today, in a summary, kind of what our ask of the supply chain is, because we're all on this journey together, is that we're obviously asking that for the supply chain to take responsibility for the emissions associated with their own their products and materials and their own operations. We're asking for sharing of knowledge, data and information to build where there are current data gaps, and I previously mentioned the areas around MyICA and ICAT, are areas where there are particular data gaps at the moment. And just like we've been asked to do, we're looking for everyone to take up the challenge to identify opportunities to reduce carbon, whether that be in the design, the materials, or in the construction. And finally, looking at innovation to find new ways of delivering lower carbon products. I mean, obviously, technology moves on so rapidly these days. We need to keep an open mind, because we're awarding frameworks now that might be with us for the next 6 to 12 to 18 years. So within there, we need to ensure that we continue to allow for new innovation. And I think, as I've indicated, given our target is to get to net zero, there is no area that we can leave unturned and investigate as to how we reduce carbon. Thank you, Andrew.
Many thanks, Ian. I'll switch my mic back on and my own feed back on there. Thank you very much for your presentation this morning. Thanks to all of our speakers. We had one question that came through, Ian, as you were speaking. I hope you don't mind, but we were asked if you could just explain the commitment to host or generate 300% renewable electricity by 2030. Could you just say a little bit more about that commitment made by Scottish Water, the 300% renewable electricity by 2030?
Okay, I'll do my best. It's not a sort of kind of prime area for myself. However, obviously, because Scottish Water has land, within Scottish Water, we do have some hydro schemes, and through previous investment periods, we've built some more hydro schemes, and obviously we've got some of them going forward. But our grid electricity emissions make up sort of kind of 60 odd % of our carbon footprint. So obviously it's an area that we are keen to reduce, and we have made good strides in that. In terms of we have wind farms, we have PVs on sites, across our area, and I think at the moment, if I'm correct, we're roughly around just north of 200% renewables. So we've still got more work to be done there, but certainly as projects come forward, we're having to look at what is the opportunity for that additional renewable electricity.
Yep. Okay. Thank you. We're kind of getting close to the end of the webinar now, but as ever, one question seems to beget another question. So another couple of quick ones, if you don't mind. Clive, the previous speaker, was asking Ian around Scottish Water's adoption of a methodology to assess and calculate carbon impacts. Can this methodology be rolled out through and across your own supply chain with support from Scottish Water itself?
Yeah, so currently we have a carbon accounting tool, commonly called the CCAT. That's open source. That is within certainly within the construction partners. They use that on their projects. Some are using it on smaller projects, some larger projects. We're also looking at going forward, getting that information into our benchmark estimating systems, so that we can, as we go through the project life cycle and we produce cost estimates, we can actually get the carbon of individual projects. But as I say, the CCAT tool is sort of kind of open source, so it is available should anybody want it. And I would ask that they make contact with our carbon team.
Excellent.
Wanting that.
Yeah. Thanks. You might have already answered the next question, but it's around standardization of carbon measurement, and CCAT, I guess, goes some way towards that. It's a question from Alan Sandilands, Resource Features. Have you found any issues around standardization of carbon measurement? And if so, do you have any observations on those?
I think the area that we've been concentrating on to date is trying to close some of the data gaps. So mentioned a few times the MyICA and ICAT data. Those are we're having to probably look at 2 or 3 streams of activity there, working with the product manufacturers themselves, but also with the industry as a whole. So we'll probably need to take a few tacks there to close those data gaps.
Yeah, thanks. Just one final one, because I realised we were due to close the webinar at 10:45 and we're running just slightly over. Any thoughts on carbon reduction from plant and pumps used to complete the projects, your projects? This question refers to a site at Selwood, where there's been heavy investment in new pumps in order to meet emission reduction targets, particularly those set by HS2 and Greater Authority London. It's obviously a site in England. What are Scottish Water's aims around carbon emission reductions for plant and machinery that you use?
I'm not quite sure I could answer that question or give it justice. In terms of, obviously some of our contractors already have started utilising some of the electric JCBs that you see, if the slide is still presentable, you see on the left-hand side. So yep. Obviously we're encouraging people to adopt the technology. Obviously, we need to make sure that it's sort of kind of truly sustainable. I mean, again, in terms of pumps and things like that, we are trying to put new pumps in that are more intelligent in the operation, so that it gives us not only carbon benefits, but maybe also benefits in terms of how the operations, the network acts operationally. So, we are keen to look at any new technology that comes forward. As I say, we can't leave any area unturned to get to net zero.
Yep. Okay, great. Thanks a lot. Probably just leave the Q&A feed rolling, because there's some quite good conversations happening in that, and we can't sort of draw out the webinar continually this morning, but I think it's quite interesting to people who are specifically raising certain points to engage with one another. It's an interesting output from the webinar, and we'll leave that sort of conversation feed live for the next sort of half an hour or so people can answer each other's questions on that. But all it remains for myself to do is to thank the this morning's speakers, again, Clive, Ian and Chris. I hope the content and information presented through this morning's webinar has been useful for everybody. Clearly, there's further information about all of these issues on our speakers' websites, Scottish Water that Ian's referred to, and Leave and Seat from Chris's point of view, and clearly Zero Waste Scotland as well, thinking back to Clive's presentation. Ourselves, from our point of view, referring back to the range of resources that we've got, all completely free of charge to the industry. So I'd encourage anyone taking part in this morning's webinar to join the school who is not already a member, and review and begin your learning journey with the school using the resources that are available online. Thanks everybody for taking part. We've had over 100 participants this morning, so really well attended webinar, which shows the interest levels in this particular agenda across Scotland. So we'll leave that Q&A feed rolling. We'll send everybody the link to the record of the webinar so everyone has the information at their fingertips. And stay safe, everybody. Look forward to presenting to you again soon. And thanks again for participating. Enjoy the rest of your days. Bye-bye.